Okay. Good afternoon, ladies and gentlemen. I am Associate Professor Shamsullah Gambari, and it is my honor to welcome you all to uh, the ninth International Conference on Applied Sciences, Engineering, Technology, and Management. Uh, I am honored to be a keynote speaker of this conference, and uh, a part of my presentation will be delivered at this webinar, Applied Innovation for Sustainable Future, Integrating Sciences, Technology, and Management. In this webinar, I talk about the concepts of distributed system and distributed computing, which while continuing the discussion of my keynote of the conference in August 2026. Okay, uh, let me uh, continue this webinar. The webinar is Applied Innovation for a Sustainable Future, Integrating of Science, Technology, and Management. The title of my talk is Trade-offs between distributed systems and artificial intelligence. As I said, in this webinar, I only focus on the first part of my keynote, which is distributed computing and artificial intelligence. Uh, Before starting my presentation, I would like to I would like to express my deep appreciation to the organizers of this webinar and conference, giving me an opportunity to share my contribution with you. And I am excited that I am a part of this conference as a keynote speaker. Uh, uh, this is something about me. Uh, as I said, I am uh, uh, associate professor of computer science, Islamic Azad University, Ashtian branch, Iran. I am also a researcher at the School of Computer Science, Institution for Research in Fundamental Sciences, IPM Tehran, Iran. Okay, I have more than 20 years of experiences in teaching and researching uh, uh, in the field of artificial intelligence uh, and distributed systems and distributed computing. I have also uh, I have also more than 50 published paper in the peer-reviewed journals and conference proceeding related to distributed systems and artificial intelligence. Okay, once again, thank you so much for considering time to to listen this presentation. Hope you enjoy this presentation and it be useful for you. Okay. The agenda of my presentation is distributed computing and distributed systems, concepts, challenges, and open problems. Okay, uh, which is the first part of my presentation. This part of the first part will be uh, uh, discussed in this webinar, and the next part, which is artificial intelligence, concept of artificial intelligence, the feature of artificial intelligence without distributed system, and the feature of distributed system without artificial intelligence, and a discussion and trade-off will be discussed on the in the August, okay, the conference of August. I think the conference will be 28 or 29 of August 2026. Okay. Okay, let me to start this webinar. The uh, my presentation will be sorry. I start my presentation by definition of distributed systems, what a distributed system is, and what the philosophy of distributed systems, and what is the benefit of distributed system. Okay. Actually, discussing and defining the distributed system is a difficult problem, but a classical uh, definition for distributed system can be like this. A distributed system is a collection of autonomous computing elements that appear to each other as a single coherent system. Okay? A distributed system is really sit between our actions and operating systems. Okay, the keyword here is middleware. Okay, the middleware hides the difference of operating systems, and distributed system operate concurrently. Think of a single coherent system. Okay, the distributed system is simulation of human behavior. This is a relationship between artificial intelligence and distributed system because uh, the distributed system itself is a simulated model, which is the definition of distributed sorry, the relationship between the distributed system and artificial intelligence. Okay, and if this figure we explain it and we show a distributed system, a small distributed system, which uh, uh, have the four computers. The computer 1, 2, 3, 4. Okay. Application A runs on computer 1. Application B is spread across computer 2 and computer 3. Okay. And application C runs on computer 4. In a reality of distributed system include more than thousands computer that usefully deployed. Okay. The next slide we talk about the key characteristics of distributed system, and each node has its notion of time. It means no global clock here, and the computers independent has this. The computers have the independent failures. All lead us to agreement between a core challenges, okay, and coordination, synchronization problem, and something else, okay. In the next slide, we talk about the distributed system, difference of distributed system and parallel systems. The parallel system is said to be, a system is said to be parallel system in which multiple processors have direct access to shared memory, which forms of thousands addresses. Okay, as you see in this figure, the left side is a parallel system. We have a sorry, we have a shared memory here. We have a shared memory here, and a lot of processors can communicate with by using a shared memory. Okay, some processor write and some processor read, and other processor read the data from this shared memory. Okay, tightly coupled, single address space, focus on raw performance and computation. Okay. this right side shows the distributed system. Okay, loosely coupled, local memory or per nodes, and the communication can be done by coordination, synchronization, and messaging process. Okay, in this table we compare completely this parallel system. The left side is this parallel system, tightly coupled. Local clock control is included local control clock. A very small number of processors that usefully deployed focuses on performance, scientific computing, and the right side loosely coupled local memory, no global clock control. Think of synchronization, coordination, and something else. Okay? A large number of processors that can be usefully deployed. Think of the scale out versus scale up. Okay, thousands of computers can be connected to each other. Okay, the main focus on these distributed systems are performance, reliability, availability, validity, resource, and information sharing. Okay. Okay, we continue the process and we continue the discussion with the four main goals of distributed systems. The first one is making resource accessible, meaning that we have ubiquity, availability, and access from anywhere, any time to the resources. And the next property of the next goal of distributed system is openness, which means that you can add or manipulate a component without disrupting the systems. Okay. The third one is scalability, size scalability, geographical scalability, and size scalability and geographical scalability, and administrative scalability. Size scalability means that you can add or remove lots of users without losing considerable performance. Okay. The fourth goal is distributed transparency, which was the key element of distributed system for a long time. Okay, it hides everything that must be distributed from the user side. Think of access transparency, location transparency, relocation transparency, replication transparency, migration transparency, and concurrency and failure transparency. Okay. Transparency increase the and provide the security of distributed system. It means that the main goal of transparency and the result of transparency is actually something like security. Okay, you do not know your data will be restored where. Okay, you cannot. Nobody can nobody know that where the data will be stored. Okay. The next thing that we will talk about is replication, which is important on availability of the data. The replication factor is equivalent to the number of nodes where data are replicated. The data is replicated to multiple nodes. Okay, an RF means replication factor of 1 means that there is only one copy of a row to a cluster, and there is no way to recover the data if the node is compressed. Okay. For example, if RF is equal to 1, means that the availability is 90%. If you have RF equal to 3 means that your availability will be 19.9. If the RF is equal to 5 means that the availability is 90.999%. And there is a trade-off between the performance and availability. It means that RF is equal to 7, maybe increase availability a little bit, but decrease the increase availability a little bit. And on the other hand, it will decrease the increase the sorry the decrease the performance. Okay, this is the trade-off. Okay, the next thing we want to talking about is consensus. Consensus is the problem of getting distributed node to agree on a single value despite failure. Okay, according to FLP, we have two properties for guarantee that the data, the safety of data and the liveness of data. I explain this thing. We have three algorithm for consensus, three famous algorithm for consensus, which are Paxos, Raft, and PBFT. And the figure show the simple form of Paxos algorithm with two processors, three acceptor and proposer. Sorry, with two proposer, three acceptor and one learner. This Paxos setup ensures safety if one accept fail. Okay, but completing proposal may delay process. Okay, and Paxos is a classical consensus algorithm. Raft, more understandable consensus algorithm, both ensure agreement among distributed nodes. Okay, handle failure and for partitions. Okay. Next thing is FLP impossibility, or the properties of FLP property and FLP impossibility and the safety and liveness properties. Safety means that nothing bad happened, means that system never enter on incorrect or invalid states. Okay, and liveness means that only good eventually happens, meaning that the system keep moving forward, finally complete its task. Okay. Now we explain the three types of distributed system. Three classical and application forms of distributed system is high performance computing, the second one is information system, interoperability, and transaction interaction, and something else focus on transaction and integration. The third one is pervasive computing, which focuses on mobile enabled systems. Think of IoT, health, sensors, and something else. Okay, I explained just the first one, which is the high performance distributed computing system, briefly called distributed computing. Okay, the distributed computing, main focus of distributed computing is computation designed to solve complex computation problem, harness the power of many nodes working together. Example of this model is cloud computing, grid computing, cluster computing, edge computing, and something else. Okay, this one or this are form of the high performance computing. What the cloud computing is actually based on NIST, National Institution for Standards and Technology. Cloud computing is model for enabling convenient demand network access to a shared pool of configurable computation resources, something like networks, servers, storage applications, and something else can be rapidly provided and released with minimal management or offer or effort or service provider interaction. Okay. This cloud model promoted availability and is composed of 5 essential characteristics, 3 service models, and 4 deployment models. Okay. Next, we explain the CAP theorem, which is very important in the distributed system, especially in distributed database and something else. Okay, CAP theorem in a CAP theorem in a distributed system a distributed system cannot have all 3: consistency, availability, and partition tolerance at once. Partitions of unavoidable. So you must choose CP, okay, drop availability, or AP, drop consistency, and something else. Okay, it means consistency, and here all client see the same value of data even right after update or deletes. Okay, availability means that all client can find a replica or data even in the case of partition node failure. Okay, this if a system provide the support consistency and availability, it means CA, or partition tolerance means that the system continue to work as expect even in presence of partial network failure. Okay, it means CP, and CP means that we can consider partitioning or partition tolerance, and consistency. AP means that we have availability and partition tolerance. CA means that we have availability and consistency. We cannot consider all 3 three properties at the same time. Okay. Now, in a distributed system, we cannot guarantee the 4 ACID properties. Okay, it means that in a distributed system we have a base properties instead of ACID. Means that basically available, soft state, eventual consistency. Okay, and the next step, next thing that in a distributed system is the next challenge of distributed system is the computation, storage, and computation problem. Okay, in a distributed system we have a lot of problem with the replica host right ordering and something else, which is the problem the problem related to storage and something data transfer, partitioning, load balancing of and something else. Computation means that task distribution, progress monitoring, and fail task reassignment. Okay, it means that in distributed system face three fundamental challenges: reliable communication over unreliable networks, consistent storage across replicated nodes, and parallel computation with coordination and fault tolerance. Okay? In the next and final step of this presentation, I will focus on the architecture of distributed systems, which we have two paradigms in a distributed system or architecture of distributed system. The first paradigm is software architecture, and the second paradigm is system architecture. The software architecture means that this is logical organization, how the system should be implemented. And the system architecture focus on placement, structure, behavior, and what the system means, what the system contains. Okay, and according to the system architecture, the system architecture can be classified into two types: centralized and decentralized architecture. Centralized is the simplest example of centralized is client server. In a client server, each client send request to the server, and the server reply back. And in this situation, we have a congestion problem and bottleneck. Okay, and it's not good. It's simple. Is good. This is a simple mode, which is okay, but the problem and the difficulty is something like single point of failure and bottleneck. The alternative for this architecture is a peer-to-peer model, which is we have a lot of component that can be considered as a server and as a client. Okay, the fault tolerance is okay, scalability is scalable. This model is scalable, and coordination is very easily can be done. Okay, and this model is a core model. This model is a core model, which is a simple peer-to-peer model. A core protocol is a fundamental algorithm for distributed hash table (DHT) in peer-to-peer systems, designed to efficiently locate data without any central coordination. Okay, here is a simple breakdown for how it's work. Okay, a ring. The ring of hashing. The ring of hashing. Here is a simple breakdown for how it's work. The ring and hashing. The second is storing data, efficient lookup, and dynamic fault tolerance. Okay, can think of key value store data and which hash with hash properties. Okay, hashing. All processors are equal. Every node acts as a both client and server. No dedicated coordinator. Built on overlay network, logical network over physical. Okay, and if in the final step we talk about the two structure. We can also classify the architecture of distributed system into two different types: structured and unstructured peer-to-peer model. structure node are in a structure model. The node are organized a specific distributed data structure. You can take a nice, elegant, symmetric data structure with fixed topology, routing mechanism, rule for adding or remove nodes, unstructured is chaos. Okay, including message mechanism and resource will be placed anywhere. Okay, and thank you so much for considering the time to uh, this presentation. And as I say, as I mentioned, the first of my presentation is mainly focuses on the mainly focuses on the trade-off between artificial intelligence and distributed systems. Okay, because we have a limited time for this webinar. In this webinar, I explained the main concept and some challenge of distributed systems. Okay, I will continue this problem, this discussion on 28 or 29 of August, which is the main conference. Once again, thank you so much for considering the time, and also I want to express again my deep appreciation to the organizer of the conference, giving an opportunity to me to share my contributions and my keynote in this time. Okay, thank you so much. See you in conference in August 2026. Thanks so much.